Hey, it's Mr. Harper Smith. Let's go over another way to distinguish the difference between PDF and CDF functions. How I will often think of it is with a graph. Here's a graph of flipping a coin and the probabilities. We can see here that we're flipping a coin 10 times. Each time it has a 50% probability. And here on the bottom, we can see how many successes or how many heads we get when we flip it 10 times. Is it possible that we get 0 heads? It's possible that you get no heads when you flip it 10 times. Is it possible that you get all 10 heads? That's also possible. Is it probable? Not so much probable, but it is possible, okay? So as we're looking here and we're thinking, well, what would the most likely outcome be if you're flipping a coin 10 times? Well, you'd probably get 5 heads. And sure enough, that's the most likely instance. It's almost 25%. So 25% of the time, whenever you flip a coin 10 times, because you do that all the time, right? If you flip a coin 10 times, about 10% of the time, you're going to get 5 heads. The rest of the time, the other 75% of the time, you're going to get these other numbers here, okay? You might get 6 heads. In fact, you'll get 6 heads 20% of the time. And same with 4 heads. What's that about? 11% of the time, you'll either get a 3, and 11% of the time, you're going to get a 7. 2 and an 8 looks like it's about 4% of the time. Then 0 and 10 is almost nothing, less than 1%. You will almost never get all heads or all tails. Now, if we think about it from a probability perspective, that makes sense, that you're not going to get all heads or all tails very often, okay? Let's look at another one. Here we've got rolling a 4-sided dice, okay? Each side has a 25% probability of getting picked, where N, we have 20 rolls. And as we're looking at this, what would the most likely outcome be if we're trying to get a 1? Well, if there's a 25% chance of getting a 1, we roll it 20 times, that means that we're probably going to get somewhere around 5. And sure enough, 5 is the most likely outcome. 4 and 6 are also pretty dang close. 3 and 7, you see it start to drop off. 2 and 8, it starts to drop off a little bit more. Then as you get out towards 11, 12, 13, 14, all the way up to 20, it's not very likely that you would get, will that be 11 or more ones? It's not likely. It's not going to happen at all, almost never. You might have a 1% chance. If you did it 100 times where you rolled 20 dice, maybe one of those times you would get 10 or more, okay? Now, that's all PDF. Each of these represent a singular PDF function. Same thing with the coin, okay? Each of those represent a singular PDF function. I'm gonna pause this real quick. All right, I'm back. So each of these represent a singular PDF function. So here is the PDF for 5. Okay, when you're in the binomial PDF for 5 successes, this is what the calculator is telling you. It's telling you the height of this bar on this histogram. If you're doing it for 3, if we want to know what's the probability of 3, the calculator is going to tell you how tall is the bar here at 3, the histogram. Okay, that's what it's telling you. Now a CDF is going to tell you what is the height of all the bars if you add them together up to that number. So if you're doing a CDF of 3, it's going to add 0, 1, 2, and 3 together. Okay? Because a CDF is what is the probability that at most 3 coins are heads when you flip 10 coins. Well, in that case, it could be 0, it could be 1, it could be 2, it could be 3. So it adds all 3 of those together. If we want to know what's the probability that at most 7 are heads, well, your calculator, it adds everything up to the 7. Okay, so it'll add 0 plus 0.1 plus 0.4, sorry, 0.01 plus 0.01 plus 0.04 plus 0.11 plus 0.2 plus 0.24 plus 0.2 plus 0.11. It would add all those together, and that'd be the combined probability for the CDF function. Okay, we're looking at rolling the dice, what's the probability that at most 10 of them are a 1? Okay, most of 10 of them are a 1. What it's going to do is it's going to look up to this 10, and it's going to add the heights of all the bars. And if we're looking at that, that would almost be 1. That would almost be 100% of the time you're going to have 10 or less be a 1. All right, so let's look at a specific example. Here we go. If this was a PDF function, the word here would be exactly 10 times. What's the probability that you would get a 1 or 2 exactly 10 times when rolling a dice? 15 times. If it's a CDF, it would be at most. So let's work with CDFs today. So we're going to use the word at most. So let's get our calculators. All right. So we're going to go on. We're going to go second, distributions. And we're going to go down to binomial CDF because it's at most. Okay, so at most, how many times do I roll the dice? 15. What is the probability of a success on each one? It's 1 out of 6. Okay. Actually, no, I'm mistaken. Here, you could roll a 1 or a 2. That'd be considered a success. So if you have a 1 or a 2, it's successful. Thus, it's actually 1 out of 3. You could also say 2 out of 6. 2 out of 6 would also be okay. The calculator knows the difference. You have 2 ways to be successful out of 6. That simplifies to 1/3. You can put either in. Then finally, what is the maximum number of allowable successes? It's going to be 10 right here. Okay? 10 is the most. Close parentheses, hit enter. And it looks like if we're rolling a dice 15 times, there's a almost 100% chance that at most 10 of those will be a 1 or a 2. Okay. If we think of what it should be, if we roll a dice 15 times, how many times would we expect to get a 1 or a 2? Well, you'd probably expect about 5 of those to be a 1 or a 2. You'd expect a third of the 15 to be a 1 or a 2. So 5 is what we would expect. So if we go back to this graph right here, a 5 is what we were expecting. We're saying anything up till 10, isn't that kind of the same idea? It's a 4-sided dice instead of a 6-sided dice, but it's kind of a similar shape. We're looking at getting 10 of those. That's almost 100%. Okay, so that's at most. Let's try another one. You draw 400 cards from a standard deck with replacement. So that means you can put them back in. You could draw a card twice. What is the probability that you draw an ace or a heart no more than 10 times? Sorry, not 10 times, 100 times. Well, a heart, if you think of a deck of cards, there's 4 suits. Hearts is one of those suits. So 25% of the cards are hearts. So we're saying, what's the probability that's going to be 100 out of 400? And it's about 25%. So my guess is that's going to be a relatively high probability. So we're drawing 400 cards. What's the standard deck? Okay, it's binomial, it's CDF. How many trials do we have? No more than, that's the same as at most. We have no more than binomial CDF. How many trials? We have 400. That's how many times we're going to draw cards. Okay. What is the probability of drawing an ace or a heart? This is where it can get a little tricky. Okay. In a deck of cards, there are 52 cards. Drawing with the mouse can be tricky. Don't judge. All right. All right. So there's 52 cards total. 25% of them are hearts. Well, what's 25% of 52? Well, if I use a calculator, it's not going to let me draw that way. 25% of 52, that means multiply. So 13 of them are going to be hearts. How many are going to be aces? How many aces are in a deck of cards? There's 1 per suit. 13 of them are going to be aces. How many are going to be hearts? 1 per suit. There's 1 per suit. There's 4 suits, so 4 of them are going to be aces. And 13 are hearts. I know I should have done that in red. No, I'll color it in for you. Yay, it's a heart. A couple months late for Valentine's Day, but whatever. That looks absolutely horrible. Okay. All right. So you might be tempted to say, oh, there are 17 possible cards you can draw. There's not 17 possible cards you can draw. Because isn't one of these aces also a heart? So that ace that's also a heart, we can't count it twice. So really, if you're counting those 13 hearts, there's only 3 aces left that we would count. So there are 16 possible cards that we could draw out of 52. Okay. That is my probability. If you want to simplify it, you're more than welcome to. Okay. So I got 16 divided by 52. Then what is the maximum number of these cards that I want to draw? It's 100. All right. Now let's see, what is the probability going to be that we draw no more than 100? 0.6%. So Harper Smith was actually wrong. It's not a very high number. Okay. If we draw 400 cards, what's the probability that 100 or less will be 16? Sorry, 100 or less will be aces or hearts. It's not a very high probability. All right, I want you to try one real quick, okay? I need to figure out how to get rid of my annotations. Clear them all. Clear all drawings. There we go. All right, I want you to try this one. Pause the video, get the answer. If you flip a coin 20 times, what is the probability that you get at most 3 heads? What is the probability that you get at most 3 heads? Okay, go through and figure that out. Then here in a sec, I'm going to show you how to do it. All right, you should have paused it. Here's how we're going to find the answer. We are going to get our handy dandy calculator. This is going to be a CDF function. And we have 20 coins, comma, that's how many times we're going to flip. What's the probability for each one? 0.5. And what is the maximum number of heads that we want? 3. Okay. Hit enter. It's a 0.1% chance. Is it very likely that if you flip a coin 20 times, 0, 1, 2, or 3 of them will be heads? It's not very likely. Think about it, it should be closer to 10. That is closer to what it should be. That doesn't mean that's always going to be 10. That's closer to what it should be. It should be closer to 10. So 3, it's not very likely. 2 is even less likely. 1 is not likely at all. 0 is almost impossible. Okay? Not entirely impossible, but almost impossible. So when you add all those up, the probability of rolling of flipping 0, 1, 2, or 3 of them to be heads, it's only about a 0.1% chance. All right, now let's take this and look at it from a totally different angle. What if instead of a maximum of 3 heads, we want a minimum of 3 heads? In that case, it could be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, or 20 of those coins can be heads. What's the probability now? Well, we want a minimum of 3. I'm gonna do a little drawing. So if 3 is the minimum, if we want 3 or more, okay, but a CDF will only tell you up to a certain number. So a CDF will only tell you up to a certain number here, okay? It'll tell you at most. It won't tell you at least. So if it won't tell you at most, how would we solve this problem? Well, what if we found this probability here of up to 2, at most 2? If we found the probability of at most 2, wouldn't the opposite of that be at least 3? It actually would. Okay. So let's find the probability of at most 2 of these. So I'm going to get my handy dandy calculator. I'm going to change it to a 2. Okay. At most 2. And that gives me all next to 0. Okay. What's the probability that at most 2 of them are heads? It's almost nothing. So to find my answer now for 3 or more, what is the overall probability going to add up to for each of these cases? It's going to be 100%. So if this is the probability for 0, 1, and 2, 1 minus, that's not a minus sign. 1 minus whatever 0, 1, and 2 are is going to tell me what 3 through 20 will be. 99.97% chance, 99.98% chance. Since this is IB, you'd almost just round it up to a whole 100% because it's almost guaranteed every single time to have 3 or more heads. You will rarely ever see 0, 1, or 2. Okay? Let's try another one. How do I get rid of my annotations? Clear all. There we go. All right, you roll a dice 15 times. What is the probability that you get a 1 or a 2 at least 10 times? What's the probability that you get a 1 or a 2 at least 10 times? Well, let's go through and write out some of the things that we need to know. Okay. How many trials am I going to have? 15. Okay, we have 15 trials. That looks horrible. Maybe I'll try writing with my finger. Okay. What is the probability for each of these dice? What's the probability of rolling a 1 or 2? The probability for rolling a 1 or 2 out of 6. Well, there's 2 possible outcomes. There's 2 desired outcomes, but there's 6 possible outcomes. So that'd give us a 2 out of 6 probability of getting a 1 or 2. You might also call that a 1 out of 3. Okay. All right, now the last one is, what is the minimum number that we would not want? Okay, it's this at least 10 times. You might be tempted to put a 10 into the calculator, but we don't want to put a 10 in because we want 10 in our answer. So instead of 10, we're going to have to do one less than 10 because the CDF, it'll do everything up to a certain number. In this case, we want everything up to 9. So when we subtract, we can get the opposite. So that would give us what letter do they use? N. And we want N to be 9 when I plug it into the calculator. So we're going to do a binomial CDF. We've got 15, 1/3. You could also do 2/6, 9. 0.991. That's the probability of getting at most 9 1s or 2s. But we want at least 10. So what's the probability of getting at least 10? Well, we have to do 1 minus this. 1 minus that answer. You got about a 0.8% chance. Is it very likely? No, it's not very likely at all. Okay, that would be your answer there. So when it's saying at least or more than, you're going to have to do 1 minus whatever the binomial CDF is. When it's exactly, you're going to do binomial PDF. When you're doing at most, that would be a binomial CDF. All right, at least you have to do 1 minus whatever the binomial is. Binomial CDF is. Let me clean my annotations. And we've got one more. I want you to try this one. I'll link a couple more videos down below to try to help you a little bit more if you're still confused. If you're still confused after watching a couple of those other videos, let me know. I will happily and gladly do a couple more videos or do some one-on-one tutoring with you guys. So You draw 400 cards from a standard deck with the replacement. What is the probability that you will draw an ace or a heart at least 10 times? How many aces or hearts are in a deck? That's your hint. Out of 52. All right, pause it, give it a try. All right, now I'm gonna do it. Here goes the answer. So the probability, sorry, not the probability, the number of trials is going to be 400. The probability of getting an ace or a heart is 16 out of 52. And finally, n. For the binomial CDF that we're going to plug into the calculator, what is the number that we're looking for? It's not 100. Is it 101 or is it 99? It's going to be one less. It is 99. All right, so I do my binomial CDF. I've got 400, comma, 16 out of 52, comma, 99. Enter. And that's the probability. It's 0.0046. So it's not a very high probability for up to 99. But remember, we don't want this number. We don't want 0 to 99. We want 100 to 400. So from 100 to 400, how do I find that answer? I'm going to do 1 minus whatever that answer is. Oh no, my calculator. So you've got a 99.5% chance of getting at least 100 hearts or aces when you're drawing 400 cards from a deck. Okay? Awesome, awesome. The expected value here, this is just a total side note, 400 times 16 divided by 52. What would we expect? How many would we expect to draw? We'd expect to draw 123. So the probability of getting 100 or more, if you were taking into account the expected value. So you're going to have a pretty high probability there. Anyway, so that's it. There are more videos linked down below. There are also a couple questions. Give them a try. Holler at me if you need any help. Please, please. I'm more than happy to help you. I'll see you next time.